Everyone, in this video we're going to solve this system of equations by Gaussian elimination with back substitution. We're going to turn this into an augmented matrix. Our goal to make it in row echelon form, which is just a leading one in each row, as it appears right here. And we'll use the 3-row operation rules. We can switch any rows at any time. We can multiply a non-zero number to any row, like we can multiply -1/3 to row 2. We just can't multiply a 0. And then the third rule, where we can multiply a number to a value in a row, add it to its corresponding value in another row, and that result will get stored in that other row. And you'll see it once we start this process. We'll use this third rule to make zeros appear. We'll use this second rule to make the ones appear. So we'll get started. The first thing is we want to make this top left number a 1. Alright? And before you start, we should actually even make the matrix out of here, which is simple. The augmented matrix, just put all the coefficients down. That's a 3, that's a 1, 2, 31. We'll use a vertical line to represent all those equal signs. That's a 1, that's a 1, that's a 2, that's a 19. That's a 1, 3, 2, and 25. Okay, so there's the augmented matrix representing those equations. But if I want a 1 to be in this top left corner, I could switch rows, correct? I could actually switch row 1 with row 3 or row 1 with row 2. Well, I'll switch row 1 and 2. I'll just switch them around. So this becomes 1, 1, 2, 19, and the second row is 3, 1, 2, 31. And then I'll leave row 3 as is. Alright, there we go. We'll double check. Yeah, we just switched around row 1 and row 2. Looks good. Alright, if you want to label that, you can put R1 and you can put this double arrow if you want for row 2. Now, this is our new row 1. This is row 2 and this is row 3. Check this off. We're going to work downward. We want a 0 in this location. Notice it's a 3. So we want a 0 to appear. We use this rule. So, because this is located in column 1, it's a 3. The opposite of a 3 is a -3. So I'm going to multiply a -3 times row 1 and add it to row 2. Okay? And the result is going to get stored in row 2. I'm going to do this to each pair of corresponding values, and I'm going to store each result in row 2. So row 2 is going to get replaced. So row 1 is going to stay as is. It's a 1, it's a 1, it's a 2, it's 19 right there. I'll pull this down. Now, here we go. I'm multiplying -3 times row 1, and then add it to row 2. -3 times a 1, add a 3 is 0. Boom. Yeah, that just replaced the value in row 2. That's what we're saying here. That's why I circled row 2. It's going to replace that value. But I have to do it for each corresponding pair of values. So, -3 times 1, add a 1, -2. -3 times a 2, add a 2, -4. -3 times 19, add 31 is -26. Okay? And check this off. Yeah, so when we're trying to change a value in row 1, in column 1, and turn it into a 0, we use row 1. That's why I used row 1 to do it. So I want to change this value next. Notice it's a 1. But we desire 0. We use this rule again. Okay, what's the opposite of a 1? -1. This is in column 1, so we'll use row 1 to do it. So I'll label it right here. We're going to multiply a -1 times row 1. Alright? I'll put a times between these. And I'm going to add it to row 3. And that result will get stored in row 3. So I'll circle this just to tell you where this is getting stored. So here we go. Ready to do it? -1 times a 1, add a 1, 0. -1 times a 1, add a 3, 2. -1 times a 2, add a 2. 0. And negative 1 times a 19, add a 25, 6. Moving on. This process isn't that bad. So we've now completed column 1. It's good to go. It's good to go. So now we'll move into this next column. This can be any number, so we'll leave it. But we're going to go right there for that location. We need it to be a 1. Notice it's a negative 2. To make 1s appear, we use this rule. Very simple. It's a negative 2. Just divide a negative 2 in that entire row. Okay, the same thing as dividing a negative 2 is multiplying a negative 1/2. So that's what we're going to write. And then we're going to multiply a negative 1/2 just to row 2. That's it. That's all we're going to do. And it's going to change each one of the values in row 2. So row 1 stays the same. 1, 1, 2, 19. Now row 2 is going to change. Negative 1/2 times a 0 is a 0. Negative 1/2 times a negative 2 is a 1. Negative 1/2 times a negative 4 is a 2. And negative 1/2 times a negative 26 is a 13. Okay. And we didn't do anything to row 3, so I'll rewrite that. Alrighty. Moving on. Doing alright here. Yes, some students like to say divide a negative 2 to each value. It's the same thing as multiplying a negative 1/2. Now we're moving downward. Alright, we need that 0 right there. Now it's in column 2. We will use this rule again. This goofy rule. To make the 0 appear. Because it's in column 2, rather than using row 1 like I did before, see how I used row 1 right there and I used row 1? Because this is located in column 2, I'll use row 2. So, what's the opposite of a 2? A negative 2. So negative 2 times row 2, add row 3. That's what I'm going to do. And this result will get stored in row 3. Alrighty. Now, let's see what we get. Okay. After I do this operation, this is still 1, 1, 2, 19, 0, 1, 2, 13. Negative 2 times a 0 plus a 0, 0. Negative 2 times a 1 add a 2, 0. Negative 2 times a 2 add a 0 is negative 4. And negative 2 times a 13 add a 6 is negative 20. Alright. Check those off. Almost done. Now we can work on column 3. And look at this. These can be any numbers. Leave those alone. But this last number right here, that bottom right corner right there, not this number, we need to make it a 1. Okay. To make 1s appear, very easy. Here, divide a negative 1/4. Okay, divide a negative 4 in the entire row. So I'm going to write negative 1/4 times row 3. And let's see what we get after I do that. I get 1, 1, 2, 19. We can get this out of the way so you can, I want to keep this lined up with this. 0, 1, 2, 13. And here we go. Multiply a negative 1/4, stays 0. Multiply a negative 1/4, that stays 0. Multiply a negative 1/4, that's a 1. Multiply a negative 1/4, that's a 5. And this is now in REF form, row echelon form. Now all we have to do is put the variables back, and we'll have this thing solved. Yeah. And when this is in row echelon form, so all I have to do is, yeah, these have variables. These are the coefficients to the variables. So what we have here is x plus y plus 2z equal to 19. In this row we have y plus 2z equal to 13. And this last row we just got 1z equal to 5. Alright. Now what's our answer? We know what z is. So I'm going to make an x, y, z space here. Z is 5. We got z. But to find your y value and to find your x value, we're going to perform back substitution. This is real easy. Yeah, take this, back back up and substitute it right there. That one, you'd have y plus 2 times 5 equals 13. Y plus 10 equals 13. If y plus 10 equals 13, y is 3. See how I got that? So this is now going to be a 3. Z equals 5, y equals 3 by me substituting it right back in there. Now y is 3, z is 5. How do I get x? Back substitution. Yeah, let's take this z equal to 5, back it up, put it right there. We'll put the value for y right there. Remember, y is a 3. And we'll have x plus 3 plus 2 times 5 equals 19. X plus 3 plus 10 equals 19. X plus 13 equals 19. X equals 6. There's our solution. X is 6. Y is 3. Z is 5. We have now solved that system of equations. And you can check it if you want. Substitute these back in each one of these two equations. You'll see they all come out as true statements. And that's Gaussian elimination with back substitution. That's it.